We're going to pick up where we left off from the previous video and look at another example utilizing this same data set. This is still 116 length measurements from abalone. The sample statistics are all the same. About 17.368 centimeters was the average abalone length. The standard deviation was 3.3 or so, and these are all in centimeters. The difference here is that we're going to create a 99% confidence interval, whereas in the previous example we did a 95% confidence interval. Okay, I'm going to scroll back up to our formula. It's at the very top here. Notice our sample statistics are the same. The point estimate x bar, the standard error s over square root of n. Because we are changing the confidence level, the only thing that's really going to be affected is this t critical value. So that's the only part of our formula that we need to reconsider. We're going to need our t-table, and the degrees of freedom, well, that's actually going to stay the same as well because that was based on sample size. What will change is the column that we go to in the t-table, which refers to the complement of the confidence level, alpha over 2. Okay, so let's go think about what is our new t-critical value. As mentioned, the degrees of freedom is the same. So 115, because it's the sample size minus 1. We said that we're using 100 though, because that's the closest on the t-table. Since the confidence level is 99%, the significance is 0.01, but that will be chopped in half, 0.005. Now I know where to go on the t-table. We're going to go to the appropriate degrees of freedom. I'm going to write 115, but we know we need to go to 100. And the column that says 0.005, that corresponds to 99% confidence. Let's take a look at our t-table. Okay, I've got my cursor here on the correct column. I'm going to scroll down to 100 degrees of freedom. It appears that we need to look at this row, and I've highlighted the t critical value that we need for this confidence interval. And as a way to check your work, we can see that this very bottom row says confidence level 99%. So that's good. Our t critical, 2.626. Let's create our confidence interval. Again, the confidence interval starts with the sample mean, add and subtract our t critical value, and that's going to be multiplied by our standard error. Now, we already computed the standard error above, but I am going to write it in its entirety for completeness here. So now we're going to do some multiplication and some division. From earlier, if you scroll up or rewind the video, we can see that this standard error was 0.312. But now I need to multiply the standard error by this new t critical value. 2.626 multiply 0.312 to get 0.819. Now that we are in this stage, we have our margin of error being added and subtracted from our point estimate. So we only have one last set of steps to perform here. I'm going to take that sample mean and subtract the margin of error, and I'm going to repeat that, but I'm going to add the margin of error this time. Okay, I'm going to report this in interval notation. That's kind of how I like to write it. 16.549 up to 18.187 centimeters. Going to double check my math here. Very good. Okay, this is our 99% confidence interval for the mean, population mean abalone length. 99% confidence interval for mu. Now let's compare this confidence interval with the 95% confidence interval that we computed from earlier. I'm going to scroll back up and maybe copy paste what we had earlier. Okay, so I copy and pasted our previous work up here from the 95% confidence interval, and let's contrast the 95 with the 99% interval. So one thing I want to notice is that since we increased the confidence level here, the t critical value went up, right? Earlier it was, I believe, a 1.984, and now it went up to 2.626. That resulted in a larger margin of error. As such, the 99% confidence interval is larger. This is because a larger percentage of random samples from that sampling distribution perspective now must contain mu in those confidence intervals. I kind of think about this as casting a bigger net. That's not a technical term in any way, that's just kind of a cute term I've made up. In general, a larger confidence level will result in a larger interval, all other things being equal. One question I will pose to you is, what effect does the sample size have on a confidence interval? For instance, in this scenario, we had sampled 116 individuals. What if we had instead sampled 600? How would this affect the ending confidence interval? Well, let's see where sample size is inserted into this formula. Sample size plays a role right here in the denominator of the standard error. As the denominator increases, that's going to take the entire standard error into a smaller value. Therefore, a larger sample size is going to decrease the margin of error.